Possibly. Yes. You're welcome. So yesterday we talked about direct and inverse variation. Now we showed direct variation. Let's see the back page. Direct variation as y equals ax, or y over x is equal to a. In inverse variation, we showed it as y is equal to a over x, or x times y is equal to a. And it's kind of just two different ways to write the same formula. We just manipulated it a little bit. For direct variation, when we talk about something being a direct variation, as one value increases, the other value increases as well. Or as one value decreases, the other value decreases as well. They go in the same direction. They're direct. Now, inverse is kind of going their opposite directions. One's going up, the other's going down. Or is one's going down, the other's going up. They go in different directions. And we went through yesterday and kind of talked about some and kind of being able to notice which equations were direct, which ones were inverse. And normally, if it's neither, it's got addition or subtraction. And what we're doing today, and this is kind of where we left off yesterday, is looking at these sets of problems, these sets of numbers, and trying to determine whether they are direct or inverse. They have a direct variation or an inverse variation. Now, this is really coming into, let's see here. Now, yesterday, before we ended, I wrote y over x equals a, and x times y equals a. I wrote these two down and said this is kind of key to solving these here and figuring it out. Well, a is just a constant term, yes? So through a set of numbers, if they have a direct variation or inverse variation, then that constant term should be the same for any set of numbers, yes? Because the constant should be the same. It is constant, yes? So that means if this here is direct, if I take the y value, negative 12 and divide it by 2, I should get the same value if I took what? Negative 6 divided by 4. Or if I took negative 4 divided by 6. Or if I take negative 3 and divide it by 8. Because if this is direct variation, I should have a constant term when I compare this x and y. Yes? Because if it is a constant, a is constant, it is just a number, it should stay the same. Well, what is negative 12 divided by 2? Negative 6 divided by 4. Well, we know one thing it's not. It's not negative 6, correct? Because this here is going to be negative 1 and a half. Okay. And again, if this is going to be direct variation, the constant term needs to be the same. It needs to be the same across all of them. So one thing we can say for sure is that this is not a direct variation. So we can try inverse, and we're multiplying x and y. So that would be 2 times negative 12, which is negative 24. What's 4 times negative 6? Negative 24. How about 6 times negative 4? And 8 times negative 3. So this here would be, this here is an inverse variation. Now, if we look at the numbers, 2 to 4, 4 to 6, 6 to 8, each x value is going what? We're adding 2 to it. It's increasing by 2, yes? Well, on the negative side, it's a little weird to see, but the negatives are decreasing. They're getting smaller. So this one here would be inverse. This here is an inverse variation. So it would be, that would be it, because again, as one increases, the other increases also, yes? So now we just need to use the math, calculate with y over x just to make sure. So it would be, well, 2 divided by 1, which is 2, yes? And then we would do 4 divided by 2, which is 2. So this constant number is the same with all of these, yes? So we can say it's direct. I don't need to check anymore. We're good, right? Oh, okay. So 8 divided by 3, is that 2? Well, no, that's 2 and 2/3. So does it have that constant change or the constant amount for all of these here? Do we have our constant term? Well, no, this is neither. So that confirm it, yeah. So it's a good way to determine which one are we going to have. Is it going to be direct or inverse? And as soon, just like with the first one, as soon as this constant term is not the same for all of them, we stop. But it has to be the same for every single one. So on the first one, well, the second one didn't give us the same value, so we're done with that. So this here, the second one tells us it's not direct. We move on to inverse. If it doesn't work with inverse, then it is neither. Because we could look at this as inverse, multiplying the two. Well, the first one would be 2 times 1, which is 2. The next one would be 2 times 4, which would give me 8. It doesn't work. So this is neither. Any questions on either one of these here? Okay, let's look at these here. So number 4, we have -4, -3, -2, 1, and 20, 15, 10, and 5. So what do we want to try first? Direct or inverse? Direct or inverse? Heard a little about inverse. Okay, so inverse would be we multiply it. So we can say -4 times 20. Well, -4 times 20 would be -80. -3 times 15. That'd be -45. So those two aren't the same, so it wouldn't be inverse. So let's try direct. So direct is going to be 20 divided by -4, which would give us -5. 15 divided by -3 is -5. 10 divided by -2 is -5. And 5 divided by -1 is -5. This would be direct. This would be direct. Bless you. And this one here, it would be tempting to say inverse, because if we look at it, -4, -3, -2, -1, it looks like this is increasing, but they're actually getting smaller negatives. And the 20, 15, 10, and 5, those are getting smaller as well. Any questions on this here? Any questions on either one of these here? Let's do this last one here. So if we look at this last one here, okay. We have 1, 2, 3, 4, 60, 30, 20, 15. So inverse. So we can do 60 times 1, which would be, well, 60. Then we would do 30 times 2, which is, well, 60. And then we can do 20 times 3. Well, that is 60. And 15 times 4 is, well, 60. And again, when we multiply the two, we're talking about inverses. So these sets of numbers here would be, well, inverses. These would be inverses. Any other questions on this here? Are we good with these here? We like these? We'll skip those other two examples and we'll move on to this here. This is the last thing we'll cover today. The variable x and y vary inversely, and y equals 4 when x equals 3, write an equation that relates x and y, then find y when x equals negative 2. So there's two things that we have to find. Well, one, we need the equation, because it says write an equation that relates x and y in this form here. Well, if it's inversely, y equals a over x. So that's the kind of equation we need. But with any equation, we don't need a. We need what value of a is. So when we find the equation, we're finding whatever the value of a is and plugging it in there. So again, on the homework, it's going to give you a problem like this, and it's just going to say equation y equals, and you put the value of a over x. That's what it's asking for. Well, how can we find that? What can we use to find the value of a? We're using this here. Y is equal to 4 when x is equal to 3. So it's saying 4 is equal to a over 3. We're plugging those values in to find out what the value of a is. Now that I've plugged those in, what can we do to find the value of a? I'm going to multiply both sides by 3. Because a divided by 3 times 3, well, the 3 and 3 would cancel out, because we would have 3a divided by 3. And 3a divided by 3 would just become a, because the a, 3 and 3 would simplify. 3 times 4 would be 12. So the value of a is 12. And we need that to be able to find the equation. Because our equation is going to be y is equal to 12 divided by x. That's our equation. Our equation is going to be 12 divided by x. Now we're almost done. We just need to find the value of y when x is equal to negative 2. So any questions on this here before we find that value of y? Okay. I'm just going to use this equation. Y is equal to 12 divided by negative 2. Well, 12 divided by negative 2 is? So that there's our equation, and that there is our answer. That's it. So that's all that there is that we need to do with this here. To find the equation, we use the x and y that they gave us to find the value of a. Once we find that value, plug it into our formula to get the equation, and then use the other x value to solve for the value of y. Any questions on this here? Because we'll do at least one or two more. Because these are going to follow the exact same pattern. And we're not going to do any of these with direct variation. We're just going to stick with inverse for these here. The variables x and y vary inversely, and y equals x when x equals 4. Write an equation that relates x and y, then find y when x equals negative 16. So that's the first thing we need to find. Well, I need to find the value of a. And we can do that by setting what up? 8 is equals 8 equals a over 4. And to solve this here, we would multiply both sides by 4. Because the 4 and 4 would cancel. should give us a by itself. And 4 times 8 is 32. Find the value of a, and we'll plug it in. And when we plug it in, we get y equals 32 over x. Any questions on any of this here? And last but not least, we've got to do what? We have to plug negative 16 in for x. And 32 divided by negative 16 is negative 2. So these here are our two answers. Any questions on any of this here? Any questions on anything we've done so far? All right, this one here will be the last one we do because, again, these don't really change in format or how we solve them. They're going to be the exact same thing. So again, since they're varying inversely, y is equal to a over x. All right, to find the value of a, we set up what? Five is equal to a over 4. And at this point here, we would multiply both sides by 4, because the 4 and 4 will simplify, leaving us with just a is equal to, well, 4 times 5 is 20. And we can take that value and plug it back in, which tells us y is equal to 20 divided by x. Now the value of x they want us to plug in is 2. So we'd have 20 divided by 2, which would tell us y is equal to 10. And that's it. And that's all we're doing.